Welcome, grade 9. We have studied a lot about straight lines. We know certain properties of straight lines. For example, we know that angles on a straight line will add up to 180 degrees. We also studied parallel lines, and we know at this stage that corresponding angles within parallel lines are equal. Alternate angles that are formed within parallel lines are equal, and co-interior angles within parallel lines will add up to 180 degrees. And now we are going to be given these things. For instance, we will be given a line, and they can ask us to prove that it is a straight line. And all we need to do really is to make use of the knowledge that we have that on a line, the angles must add up to 180. We will look at such questions. For parallel lines, for instance, you will get, say, a pair of lines, and they will ask you to prove that the lines are parallel. And to do that, all you need to do is to make use of the properties of the angles that you get within parallel lines. Remember that co-interior angles add up to 180 provided the lines are parallel. Corresponding angles are equal to each other provided the lines are parallel, and alternate angles are equal only if the lines are parallel. So we are using the same properties, and we call these the Converse Theorems. Let's look at that, but before we proceed, just a quick look at parallel lines. We have line ABF here. I hope you can see line ABF there. And we have line CDG. Those lines are parallel. But how do I know that the lines are parallel? Remember, parallel lines are lines that will never meet. A better definition of parallel lines is that parallel lines are equidistant from each other. In other words, the distance between the parallel lines should stay constant. In this case, if you look at the line AC, that is just one of the lines that we can identify in this diagram. The number of units between A and C is 5 units. If you look at F and G there, the number of units also between F and G is 5 units. If you take any other point anywhere, you will discover the distance between the line AF and the line CG will be equal to 5. So we know that these lines are parallel. And please take note, because the lines are parallel, then corresponding angles will be equal. The red angles there, that angle alpha 78,69 degrees, and this angle beta, which is 78,69 degrees, those are called corresponding angles. And remember, we said there are 4 pairs of corresponding angles. So those red angles are equal. The reason why this is so is simply because the lines AF and CG are parallel. The green angles there are also equal. Do you see that? And that is only because the lines are parallel. The blue angles are also equal. Those are corresponding angles. They are equal. And the reason is because the lines are parallel. And these other two angles, 78,69 degrees, are also equal. And the reason is because the lines are parallel. So those angles, corresponding angles, for instance, and alternate angles, for instance, will be equal. And the reason why they're equal in this particular case is simply because the lines are parallel. If we change the condition and we make our lines not to be parallel, we know that those angles will not be equal. Just look at what happens as the distance AC changes. Remember, AC should be equal to FG for these lines to be parallel. But what happens if we keep changing the distance AC? Right, so you see the gap between A and C is increasing. Clearly, the lines are no longer parallel. Now they are parallel. Clearly, now the lines are not parallel. So if I stop or pause anywhere when the lines are not parallel, we can then compare those angles that we called corresponding, alternate, and co-interior. Let me stop, for instance, here. Now we clearly can see that those two lines are not parallel. Now look at our right angles. You see now the right angles are not equal. Alpha is 78.69 degrees, but beta is 56.89 degrees. The green ones are also not equal. The blue ones are now not equal, and the pink ones are now not equal. But still, the right angles are called corresponding angles. But these corresponding angles are not equal, and the reason is because the lines AF and CG are not parallel. So if we can prove that corresponding angles are equal, then that will be enough to prove that the lines are parallel. If we can also prove that the alternate angles are equal, then we would have proved that the lines are parallel. I've got a question here. We are given a diagram where line BC is parallel to line GK. You need to look at your diagram and see that. Angle E3 is equal to 60 degrees. It is marked there in the diagram. Angle E5 is equal to 30 degrees. That's marked as well. And it says GE bisects angle HEF. So GE is this line here. And that line bisects. To bisect is to divide or to cut into two equal parts. So the line GE cuts the angle HEF into two equal parts. Those dots that you see there tell us that GE actually divides HEF into half, which means angle E1 is, this is angle E1 here, is the same size as angle E2. Now we want to show that line BE is perpendicular to line GK. The best thing you need to do here, guys, will be for you to highlight, just highlight the lines that you are talking about, because there's so many lines here. Line BE is this line here. So I'm just going to highlight that line, that is line BE there, and line GK. Angle E1 is equal to 30 degrees. The reason is these are vertically opposite angles. So vertically opposite angles are equal, so that is the reason. Then angle E2 will also be equal to 30 degrees. How do I know that angle E2 is 30 degrees? I know because this is given. We are told that E1 and E2 are equal. Remember, the line GE bisects the angle HEF. Then angle E3 you guessed right, is equal to 60 degrees. And what is the reason for that one? This is also given. Now this means if you take angle E2 and add it to angle E3, you will get 30 plus 60, which is 90 degrees. I'm just adding these two angles here. That tells us that BE is perpendicular to GK. In question 2, we want to show that triangle BED is equilateral, we actually need to prove that angle E4 is 60 degrees and angle D1 is 60 degrees and angle B2 is 60 degrees. We need to prove that. Now let's go ahead and prove that. We need a strategy here. We are looking for E4. What do we know already about E4 plus E5? We know that this must form 90 degrees. This is because we said earlier on that the line BE is perpendicular to the line GE. This was proved, so proven. But in the diagram, we are given that E5 is equal to 30 degrees. That is given. And this therefore means angle E4 should be equal to 90 subtract 30, which is 60 degrees. So there we are. We now know that E4 is 60 degrees. If you look at triangle BED, we are given that the side BE is equal to the side BD. So right now we know that that triangle there is isosceles. D1 is therefore one of the base angles of that triangle, which is isosceles. And we know that base angles of an isosceles triangle are equal. So we know that D1 should be the same size as E4, which is equal to 60 degrees. The reason therefore should be these are angles which are opposite equal sides. So base angles are equal, or you could say angles opposite equal sides. So now we know that D1 is equal to 60 degrees. The only other angle that is left is B2. Now, clearly, if you take angle B2 and you add angle D1 and you add angle E4, that must give us 180 degrees because this is a triangle. And the reason therefore should be sum of angles in a triangle. This will give us angle B2 also equal to 60 if you solve that equation. And so all the angles are 60 degrees. Therefore, we can conclude that triangle BED is equilateral. And let's look at this one here. In the diagram, we know that BC and GK are parallel. Let's not forget that. This time, we want to show that the lines EF and DB will be parallel. Remember, lines will be parallel if their corresponding angles are equal, that is number one, or if their alternate angles are equal, or if the co-interior angles add up to 180. So in this case, you need to prove any one of those three. And so we're going to use fun. So angle B2 is equal to 60 degrees. We did this, it's proven. But angle E3 is equal to 60 degrees as well, that is given. Therefore, angle B2 is equal to angle E3, which is 60 degrees in each case. We can conclude that therefore line FE is parallel to line BD because we have alternate angles that are equal. So alternate angles are equal.